That's right. Thank you. Okay, so what's the deal with that? Here's the question. Number 10, how many license plates start with the letter Z and end with a W? Right, you can use any letters except for all 26 letters in the alphabet, except for O, I, and Q. So remember how to do these things? Decisions and options, right? Decisions and options. Put this away, 4, 5, there it goes. Yeah, so if I was, let me just pick one. Excuse me, that's always helpful, I think. What do they have? They have to start with Z, end with W. So I'll go Z, A, B, C, W, for example. I just picked one, right? I just did a license plate according to their rules. 5 letters, start with a Z, end with a W. All right, so think back. How many decisions did I make? And right, it's all about decisions and options, isn't it? How many decisions did I make, and how many options for each decision? That's the key question. So I made 5 decisions, right? I chose a Z, chose an A, chose a B, chose a C, chose a W, didn't I? And then on the line, you put how many options you had for each of those 5 decisions. So for my first decision in which I decided to put a Z, how many options did I really have? Just one. I had to do Z. They said I had to. I only had one option. I couldn't do anything but Z. Same thing with the W at the back. Just had one option. Had to put a W, right? For the A, when I chose the A, how many options did I have? 26 letters in the alphabet, but you can't use O, I, and Q, so I had 23 options. Nothing in this one about not repeating. We don't have to worry about going down by 1 or anything. That's why when they say don't repeat what you've already chosen. They didn't say that here. Right? They just said pick anything you want. You just can't have O, I, and Q. So 26 letters in the alphabet, 23 options. For the B, 23 options. For the C, 23 options. So if you multiply those all together, that's really just 23 to the 3rd power, isn't it? That's why the answer was A. Is that good? We good with all that? Be able to do that on the exam just the day after tomorrow. We better get, it's not funny, but it's kind of funny. How fast we move here. We have got to get like, all right, yeah, if you have your calculator, let's do 13P2. It's simply, have we gone over this? I keep thinking we have, but have we not? 13P2? No, you know what? I'm thinking of my pre-calculus class I taught end of spring. That was like the last thing we did in there. And anyway, so I'm confusing you guys and them because there was no weeks in between. All right, so no, we have not. I need to do this with you. 13P2. Okay, y'all have your calculators with you? There are buttons on your calculator to do this. I think that'd be the easiest way. I mean, I'll show you the by hand thing too, but if you have your button, so if you have the TIs, for example, TI 84 things, it's under, what is that, under math? Yeah. And then go over to PRB. Okay, PRB can go down to there it is. So you got to first put in the first number. I should have said that first. Yeah. So you got to put in a 13 and then find the PC thing. Oh, I never know on those cassettes. I mean, there's something great. I just don't work with them. I love them, but I don't have I have the cheap ones. I don't have this one. It's probably here somewhere. How do you get change it so I can get catalog it? What's all that? Is that video thing? I don't know what that is. What's it called? It's called formation percent. I do not know. I can, at the break, I can try to type it in. You guys saw me? How good is it? Did you guys have, let me try the more normal ones. Did you find those? Yeah. Right. Good. I got that. Good. Okay. You guys, so yours is the TI 30. You got the TI? Yeah, go. You got it? You found the PC button? Is that it? I can't. My eyes are too old. That's it. In here. So do the first number, the 13, then hit the NPR, and then the 2. Then. Oh, you want to show yours? Yeah, so another math. Oh, you got it? Oh, yeah. Okay. You got it? Yeah. So yours is just like Richard's there. So.
Press the numbers. Under degree is probability.
Oh, probability. Probability, yeah, okay. So type this. So type 13, then hit the PRB key, and then go over to, NPR, it's on it right now.
Okay.
Just hit enter, and then hit the 2, and then enter. And is it, what is it, 13, so is it, what's the answer? You guys getting it over here? Got it, got it? William, you got it? Yeah. Got it? Everybody getting it? You get it okay, Sandy? You got it? Chad, you getting it? Got it. Got it?
He's getting it.
Oh, okay. Getting a calculator. So did you find it?
No.
Anywhere?
I don't know.
Yes, right here. Let me do this really quick. Or here, I'll search while I'm just. So if you've got that 13, what is the answer to 13P2? What is it? 152? 156. Okay. And then part B is 13C2. Now do the C button. See if you can find that. Y'all finding that? I'm trying to get this calculator thing, but I can never figure out. Oh, option. Option. look up the manual online. So for the, what you need to, 13, then you hit option, F6, which means more, problem, F3, there's the P and the C. So P for this one, C on the next one, P on this one, P, that's the P, and then 2, enter, there it is. We'll try that with the, so let's start a new one, it's clear, okay? So let's do this one now. So 13 first, yeah. And you get an option. Option, and then, is it, yeah, I guess so. Yeah, the problem, yeah. And then you can do P or C. Yeah. Thank you. 2. There it is. Yeah.
Thank you.
Uh-huh. So y'all getting it? 78? Right? On that one? Easy pickings. All right. And then so C. And so the rest are just hit. Can I just go da da da? Hit the buttons on your calculator, right? We'll move along. All right. So on to number 6. Now we're going to see what that P and C thing means about the real world. Why we even care. Okay. So the board of directors, XYZ Corporation is 20 members. Give your answer. NPs are in CR. How many different slates of 4 members can be chosen? B. How many delegations of 4 members can be chosen? Okay. What NPR means is out of N items, pick R and order matters. In CR, it means out of N items, pick R, and order does not matter. That's the difference. It's all about whether order matters or not. So y'all hearing me on this? It's really important stuff here. So here we are. The big difference between the NPR and the, now we're going to get real life. Like, what are these things? Okay, we can get the numbers, but what does that mean? That's a way of, like if I was to say, hey, I'm going to pick 3 people in here at random, and I'm going to give them all $10. Just off the roll, at random, boom, 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 3 days, $10, $10, $10. How many different ways? I can pick these 3, or those 3, or one of these and 2 of those. Or there's a whole bunch of different groups of 3 I could pick, right? How many different groups are there in 10C3? Right? Or how many people are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. 12. So out of 12 people, choose 3. So you could do the numbers in your calculator, whatever number that comes out to be. That's how many different groups of 3 there are out of 12 people. Does that make sense? 12 people? Yeah, 12 of us. So yeah, so out of 12 people, choose 3. Right? How many different groups of 3 are there, right? It could be these 3, or those 3, or these 3, or those 3, or one of these and 2 of those. You know, how many different groups of 3 are there out of 12? Now, if I say, and I'm going to give them $10 each. So if I was going to do that, if I was going to say, if I was going to read the list, and I went, all right, here's the people who, I'm going to grab my roll sheet. You ready, guys? Try to get the meaning here. I'm going to grab my roll sheet. Now, C means order does not matter. And if I do 12P3, order matters. Order matters. Is that good? Now, why would, that seems weird. It probably would to me. If I was like you, I'd be like, what do you mean order matters? Order doesn't matter. Well, I mean, what if I was to pick the 3 names, okay? Here, let me reverse them. What if I was to pick the 3 names? I was going to go 12P3. And here's the 3 names I picked. I picked Chad Enriqueta. How do you spell your name, Enriqueta? Here, I'll look on the roll sheet here. That's probably easier for me. There you are. Enriqueta. Enriqueta Sandeep. All right, these three up here. Let's just pick Chad, Enriqueta, Sandeep. Okay. And they get $10, $10, $10. I just picked their names at random. And it was Chad, Enriqueta, Sandeep. They'd be happy. What if instead, and how many different groups are there? What is 12? Let's do the C first. What is the 12C3? Somebody have that? What's the calculator say? What's 12C3?
220.
Isn't it 1320?
Oh, I'm sorry, I did that wrong.
Is it 1320? Am I thinking right?
220.
What is it?
220.
Is it?
220.
Okay. Oh, I'm thinking wrong. Yeah, I'm doing 12P3 in my head. Okay, 220. So that means there's 220 different groups of three in here. Isn't that amazing? It doesn't seem like there's that many. There's 220 different groups of three. Now, let me ask you guys, if I read the three names, Chad, Enriqueta, Sandeep, $10, $10, $10, that'd be great. What if instead, as I read the roll sheet and picked three names at random, what if instead I said Sandeep, Chad, Enriqueta? Would they care? Would Chad be sad that his name is second instead of first to get $10, $10, $10? No, he wouldn't care. Who cares? I don't care if I'm first or second or third. I'm just glad I'm in. I get the $10. Now, so order doesn't matter in that kind of scenario. If you're just getting $10, $10, $10. Order doesn't matter, right? Now, what if instead I said, you know what? I'm going to give $20, $10, $1. Changed my mind. The first name's going to get $20, then 10, then 1. Now, would they care whether their name was first, second, or third? Of course. So order matters when the rewards or the offices or the whatevers are different. When they're all the same, order doesn't matter. So that's what we're talking about. So when you read a word problem about this, pick out of this, pick out of 10 people, pick 2, or out of whatever, pick whatever. You want to ask yourself, are the results, are the offices or the money or the whatever, are they different? Then it matters whether those three were picked Chad, Enriqueta, Sandeep, or Sandeep, Enriqueta, Chad. That order would matter if I'm going to make one of them president, then vice president, then secretary, or $20, $10, $1, versus, hey, all three of you get $10, or all three of you are just on the board. Then order doesn't matter. You see the difference there? So on part A, they're saying what? How many different slates of 4 members? Are they different? Let me bring a fresh question over here. The question again. Look at part A. If it's president, vice president, treasurer, and secretary, those are 4 different results, rewards, whatever you want to call it, rewards or offices or positions. Those are different, huh? So the order matters, right? It matters whether your name is first, you're the president, among the 4 names that received offices, or your name is second, you're only the VP, third, you're the treasurer, fourth, you're the secretary. It matters. Order matters. So on part A, order matters. So which one does order matter? It's the P. So it's are there 20 people? Yeah, 20 members. Out of 20, pick 4. It's option C. Order matters. So it's 20, pick 4. P, order matters. That's what you do for order matters. Now on part B here, they're going to say, okay, now you're just picking 4 members, all equal. Just a delegation of 4 people. They're all equal. They're all just officers of the club. So on part B, order does not matter. You with me? So that means it's out of 20, choose 4 with the C. For the C, order does not matter. So we'll write that in your 3x5 card for the test day after tomorrow. Practice exam even tomorrow. So the C. Now, I had a friend, a colleague years ago. He used to always say, When you order it's called combination. C stands for combination. P is permutation. So C combination. You say when you order a combination pizza, you never tell them what order to put the stuff on, right? You don't order a combination pizza and say I want the pepperoni first, and then the cheese on the top, and then the tomato sauce all drizzled on the top. You don't tell them the order, right? So if that helps, combination order doesn't matter, right? Combination. C is when the order doesn't matter. You don't tell them the order when you order a combination pizza. All right? That makes sense? P, the order matters. So that's the difference. Is that good? If the offices are different, you care about the order. If the offices are all the same, the order doesn't matter. All right. Stop me if you want to talk about it. Okay, so number 7, part A. A punk rock band is planning their next concert tour. The band has 30 new songs in their repertoire. Given an answer using blah, blah, blah. Okay, so they have 30 songs. Out of the 30 songs, they're going to pick a few. Get the idea, right? So he's out of a bigger group, pick a small group. How many different sets of 10 songs can the band play? I don't know. How many different set lists of 10 songs can the band select to play? Well, does the order... See, that's not a good question. I'll make it clear on the test whether order matters. When I read that, I think, does order matter or does it not? I don't know. They're not being very clear. So they're saying, pick 10 songs. And so it's 30 C or P, I don't know what, 10, right? It's out of 30, pick 10. Out of their 30 songs, pick 10 to put on their song list, right? A set list. I guess they're saying order doesn't matter. It sounds like to me. I see that's just not clear. I think that's a bad question. On the test, I will make it very clear. Like $20, $10, $1. You'll know whether order matters or not. So I would say that question is order does not matter because it's just a list of 10 songs. It's not in any particular order for part A. And then for part B, see what they say? In the CD, the order is relevant, matters. So on part B, the order matters, so that would be the P. They're both out of 30, pick 10. It's just in part B, the order matters. Does that make sense? So part B was clear. Part A just wasn't very clear. Okay, so I'm going to move on from that if you're okay with that. Questions will be just like that on the exam. That's the end of 15. Okay, so here we are. There, when you flip 3 coins, yeah, let's talk about it. Before we get to that particular question, let me just ask a simpler question. If you're going to flip a coin once, what's the chance you're going to get heads? 50-50, half. There's 3 ways to say it. You can say it fraction, decimal, or percentage. 50%, half, or 0.5. It's all the same thing. It means half, right? Now, if I'm going to flip a coin twice, what's the chance I'm going to get 2 heads in a row? Two heads in a row. Flip a coin twice. 2 heads in a row. Everybody know? What's that? 50-50? If I get 2 heads in a row? How about this? Let's just map out everything that can happen. When you flip a coin twice, can't you get, I think this is the easiest way, is just to kind of say, well, what can happen? Can't you get heads then heads, right? Or heads then tails. You get heads first time, tails the second. Or you could get tails the first time, heads the second, or you could get tail, tail, huh? Aren't there really 4 different things that can happen when you flip the coin twice? Right? So how many of those are both heads? 1 out of 4, huh? 1 out of 4 is a chance of 2 heads in a row. Okay?
But that's only flipping the coin twice.
That's just flipping the coin twice. Yeah, I know. I'm building up slowly to their actual question. Is that good to there? It's funny. I always feel when I talk about things like this with college students, I always feel like such an alien that I'm sure I was a strange child, but I was doing this like when I was not that I'm not rocket scientist or anything, but I was just into this kind of thing. When I was like 12, 13, 14, I was doing probabilities, because I was into baseball, was really the thing. I was obsessed with baseball, and baseball has all the probabilities in the back of little baseball cards, so I would make up little baseball games with the percentages. And so it's funny to me, just to throw out the question to college students, and if you guys have never thought like about what the chance of getting 2 heads in a row, this is my life, you know, but I'm sure I'm different, I'm just weird, you know. I was always thinking about probabilities. I think the whole, the dice, the cards, the gambling, casino probabilities are I love all that kind of stuff, which it just makes me in the end know that you don't win there. They've got them all figured out. Anyway, so I don't have time for that whole thing. So now let's go. So this is for two flips. Now, what about if we flip it 3 times? If we flip it 3 times, what are all the, can you list out? Let me give you a chance. On your own paper, can you list out all the different things that happen when you flip the coin 3 times? Try to be systematic about it, but rather than random, I'll just write down head, tail, tail. And tail, head, head. And then, you know, don't be random, because then you miss some, right? Have a system, and there's all kinds of different systems. Doesn't matter what your system is. But just have some kind of methodical system so you don't miss any. List out all that can happen when you flip 3 times. So you guys didn't sit around as a kid and figure out a chance of rolling, 2 7, and a total of 7 on 2 dice, and chance of drawing to a flush with a poker hand, or this is what I was doing all the time, all that weird stuff. I thought it was interesting. But then I'm strange. Why they say don't draw to an inside straight in poker, it's because the probability is low. That's what that means. All right, so let's list out. So 3 flips. So let me show you what I mean. Here's one system. I'll just start with all heads. Heads, 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 right? That's one thing that can happen when you flip a coin 3 times. Or you could go heads, heads, tails. That's another thing, huh? Now, look, here's my system. That's starting heads, heads, huh? Those are both starting heads, heads. Now I'll start heads, tails. And I'll have 2 heads, tails start. And if you start heads, tails, you can end with a head or end with a tail. I'm always doing heads first, So that's all the heads, heads starts and the heads, tails starts, right? Now I'm going to start with tails. And I'm going to go tails, heads, tails, heads. And if you start tails, heads, you can finish with heads or tails. And then finally, I'm going to start tails, tails. And if you start tails, tails, you can end with a head or end with a tail. There they are. 8. 8 possible things that can happen when you flip a coin 3 times. What's the chance to get 3 heads in a row? 8 things are up there.
1 out of 8.
1 out of 8. So just put half each time. Chance of 1 head's a half. Chance of 2 heads a fourth. Chance of 3 heads is an 8. Probabilistically goes down, right? Is that good to there? So we play dice games at home. I always make them calculate. Yeah, no, it's important to be probabilistic. I never win, but but I'm always like, the chance of that is, and most of the time the kids are like, whatever, Dad, I'm rolling the whatever. They don't care. Some of them do. Some of them are interested. Some are not.
How
All right.
many kids do you have?
I have 5 children. It's craziness, isn't it? So there's a big number right there. Never thought I'd have 5 kids. All right. So let's take it from there. So now, what's their actual question now? Their actual question is list the ones that, what do they say? Find more tails than heads. There it is. I couldn't hardly see it. More tails. There's what they actually want from it. There's a lot of words there. Find the set of outcomes that occur when flip 3 coins and obtain more tails than heads. So let me just circle the ones that have more tails than heads. That would be, what would that be? This one has more tails than heads. 2 tails and a head. And this one, 2 tails and a head again. And, of course, all tails is more tails than heads. Those three, that's it, right? Am I missing one? Oh, and then this one. I am missing one. Those 4 have more tails than heads, right? And that's what the answer. See how they listed that in the answer up here? Any order's fine, doesn't matter. But those 4 separate outcomes. So, for example, what if somebody asked you, you're going to flip a coin 3 times, so it's going to be one of those 8 things that's going to happen. And they said, what's the chance you're going to get more tails than heads? More tails than heads. Well, out of the 8 different things that are going to happen when you flip a coin 3 times, if that happens, or that happens, or that happens, or that happens, if 4 out of those 8 things happen, you'll get more tails than heads. So, and then reduce that like any fraction, half, huh? There's a half chance you'll get more tails than heads. That makes sense, doesn't it? Because you're going to get more tails or more heads, so it's half and half. Does that make sense? See how probability works? You just got to list everything that can happen, and then just identify the ones you want. 4 out of 8. Good. We good there? All right. So they didn't want this was all they just wanted this is all they wanted was the list of the 4 things that can happen. We good? All right. So good thing. This would be a good thing to just put on your 3x5 card. That way you won't have to like think of it and be all systematic right then. Just write all 8 of them right in your 3x5 card. Or write this right in your 3x5 card. That way you just have them. So if there's a question about flipping twice or 3 times, you'll just look at your list, which is already ready to go. You know. All right. Okay. So part A. Find the probability assignment for the probability space 03, 04, 05. Probability space when 03, 04 all have the same probability. Okay. Okay. So this is kind of weird. Basically, they're listing out 5 different outcomes. Outcome 1, 2, 3, 4, and 5. Outcome 1, 2, 3, 4, and 5. Okay. And so in those outcomes, they're going to give us the PR. The PR stands for probability, like chance of something happening. Like, the probability of rain is 30% or whatever. The probability of outcome 1 happening, whatever that is, Maybe outcome 1 is, whatever they are. There are different things that can happen. So outcome 1, the probability is 0.26. The probability for outcome 2 is more likely 0.44. 44% chance that outcome 2 will happen. Okay, so here we go. They're saying, find the probability assignment when part A says 03, 04, and 05 all have the same probability. So that means 03, 04, and 05 are the same. So probability 1, I know this is 0.26. And probability 2, I know this one's 0.44. And then the other 3, I know, are all the same. So you could just call them X. I don't know what they are, but I know they're all the same, aren't they? So call them all X. And if I tell you, hey guys, there's a 70% chance of rain tomorrow. I don't think so. What's the chance that it will not rain? If it's 70% chance of rain tomorrow, what's the chance it won't rain? 30%. How do you know that right away? Because it's got to add up to 100. And 100% is the same as what decimal? Now, this is the same as 0.7, 0.3, and decimal 1.0 is 100%, right? 1.0 decimal. So all the probabilities always have to add up to 100% or 1.0 decimal, right? So if I add up all these probabilities, they have to equal, we're in decimals, right? So 1.0 decimal, don't they? Because they're everything that can happen. It's 01 through 05. That's all that can happen. Is that making sense? Maybe those are 5 race cars in a race, and the probability that racer number 1 is going to win is 0.20. The probability that racer number 2 is going to win is 0.44, right? And the other 3 all have the same probability. I don't know what it is, and together they have to add up to 1.0, 100%. Is that making sense? So now I can solve that little equation for X. How do I solve that little equation for X? What do I do? What is x plus x plus x? 3x, huh? And these add up to, I don't know, is it 0.7? Yeah, 0.7, I think, right? You get to there so far? I just added up these two to be 0.7. 0.70, if that helps, you know. Now, how do you remember algebra days? Remember your favorite days? Those glorious algebra days? I always kid around because a lot of people didn't like algebra. But Cole liked algebra. Sure. One of the few. All right. So how do you solve for x? Do you remember how to solve for x in an algebra equation like that? What do you do? Yeah, exactly. You got to subtract the points. Remember, you got the equal sign, left side, right side. Do whatever it takes to get x alone. X is, I always tell my algebra students, x is saying, I want to be alone over here. Get rid of this stuff, right? So subtract 0.70 from both sides. So then we get, bring it down here. Then we get 3x equals, what is that, 0.30 or 0.3, either way. What's the final step? X is almost alone. What's the final step to get x alone? Yeah, you got to divide. Why don't I subtract 3 there? It's multiplied. It's 3 times x. It's right next to the x. It's times. Opposite times is divide, huh? So divide, that cancels x, and that's 0.10, I think, right? Or 0.1, same thing, you know, whatever. 0.1. So the answer is 0.1. So in other words, these 3 are all 0.1, 0.1, 0.1. And if you add all those up, that'll be 1.0, 100%. Notice they each have a 10% chance, right? 10%, 10%, 10%, that's 30, and these two make 70, that's 100%. The chance of race cars 3, 4, and 5 winning the race is 10% for each of them. Like that. Are we good? Questions on that one? See, I solved the little equation. Then part B is going to be a little different, but are you okay with part A there? Question, Jenna?
Why does that say under the 70 is at 20?
Oh, no, I'm just not writing very well. Sorry.
Okay.
0.70.
70. Okay.
Yeah, I'm just subtracting. So just getting rid of that, just subtracting exactly what it is. Yeah.
Okay.
Yeah, on both sides.
That's what I thought.
Minus 0.70. Yeah. Good. Any other questions I can answer on that? That makes sense. Okay, so then let's go to part B. Same, very similar question. So part B now. Again, we have the 01, 02, 03, 04, 05. It says 05 is 0.11, so I'll just put 0.11 here for 05. Oh, and it already told me that the stuff up above still applies, right? The instructions they put up above A and B are going to work for A and B still. So 01 is what? 0.26. And 02 is 0.44. And they say, and that's weird, 03 is the same as 04 and 05 combined.
So is the first probability still the same?
05 combined. What's that? Yeah, the first two are the same. Oh, yeah, right. Good call. Right up here, right? What it says up here in the top, that applies for both A and B. Yeah, so 01 is still 0.26, 02 is still 0.44. And they're telling me 05 is 0.11. Good so far? Now, what am I going to put in here for 04 and here for 03? Well, look what they say. 03, do I know what 03 is? No. It's the same as 04 and 05 combined. 04 and 05 combined. Well, I know 05 is 0.11. They gave it to me. Could I call this one X since I don't know what it is? Just call it X. Like, just put an X in there. And then what is 03 going to be now? What's that? What's 03? What does it say here? 03 is the same as 04 and 05 combined. So 04 is X. 05 is 0.11. 03 is 04 and 05 combined. It's these two combined. Right? That makes sense? So what's 03 then? Would it be right to go 0.11x? Is that right? No, because that's times, huh? If I put 0.11 right next to x with no symbol in the middle, that means times. That's not what they mean when they say combined. What do they mean? They mean added together, huh? X plus 0.11, right? Does that make sense? Combined, the other two combined, the other two added up. So 03 is 04 and 05 added up. Is that good? Okay, great. So what now? How do I find anything?
Yeah, that's a good question.
Yeah, now remember, add them all up, and what do they have to equal? 1.0 decimal, right? We're doing decimal, 100%, which is 1.0 decimal, since we're in decimals here, right? Got to, so just stick a bunch of plus signs between them, right? Just come on down and go, okay, plus, 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 plus equals 1.0 decimal. Is that good? You see how I read those words and turned them into x's and things? Can you solve that equation now? Remember? Your glorious algebra days? Can you solve that equation? So add up all the numbers, and what is the 2x is going to add up to be on the left side? Just 2x, right? So it's going to be 2x plus what all those numbers add up to be equals 1.0. And then finish, let me let you finish that up. Solving for x there. So use your calculator, 0.26, 0.44, 0.11, 0.11. Is that 0.92? Oops, did the wrong thing there. Right? I think I did that right? We good with that? So the x and the x make the 2x. Everybody see how I got that 2x there? X and x make 2x. And then I just added up these numbers, 0.26, 0.44, 0.11, 0.11. I got 0.92. Calculator 0.92. You getting that okay? Good. And then can you finish solving for there? Finish solving for x? What's the next step in solving for x? Yeah, subtract the 0.92. 2x is 0.08. Right, when you subtract that, 1.00 minus 0.92 is 0.08. Last step. Divide by 2. Is that good? So we get x is 0.04. Is that good? So, let me move this up a little bit. This is 0.04. So what does that mean then about our final answers? We have 01, 02, 03, 04, and 05. Because they're going to ask you for all the 5 outcomes. like the 5 different race cars and what the chances they're going to win the race. So how do I figure those out? How do you do 01? Well, we already knew 01, it was 0.26. There's nothing to do. It's 0.26. How do you do 02? Same thing. We already had it, 0.44. How do you do 03? Oh, it's that formula. X plus 0.11. That was 03. So now we know what X is. Plug it in. So it's 0.04 plus 0.11, it's 0.15. For 03, we okay there for 03? See that? And now, 04. Is that too fast? We okay? Am I losing you? Everybody see what I'm doing there? Right, so I did this work to solve for x. I got my answer for x, and now I'm figuring out 01, I already had it, 0.26, 02 is 0.44, and 03 is x plus 0.11, right? That's what I had there, x plus 0.11. Plug in the x of 0.04, it's 0.15. What's 04? Just x, right? 04 is just x. So it's just x, which is what? What's x? 0.04. So we can use the x again, 0.04. And then finally 05, what's 05? Well, just 0.11, we had it from the beginning. There we go. There we are. We have all five different outcomes, their probabilities. Is that good? Questions on that? No questions? We all good? I'm going to save this.